Okay, guys, this lesson is on solving radical equations. The foldable kind of messed up a lot, so just kind of bear with me. This top flap, this first part is correct as the first thing that it has here. Um, if two expressions are equal, then their squares are also equal. So if A equals B, then A squared equals B squared. All right, so that's the same as saying, you can zoom in some. If the square root of x equals 5, then the square root of x squared equals 5 squared. Okay, so the flap says that this is radicals on both sides. This example 1 doesn't have a radical on both sides. And you can see this is example 5. So it's just kind of a mess. Bear with me flipping through. We are going to look at one side before we look at radicals on both sides. Okay, so example 1, make sure you're on example 1 there. The first thing that we're going to want to do is get rid of anything that is with the variable, which is x. We're looking for x. Well, there's two things happening with x. There's the square root of x happening, and then there's going to be an add 3 happening. We're going to have to first get rid of this 3. So we're going to subtract 3 from both sides. So I'm left with the square root of x, and it equals 7. All right, but now I do not have x by itself. What is the inverse operation of square rooting something? Is squaring it. So I squared the square root, which canceled that out, so I'm left with x equals 7 squared, which is 49. Okay, easy enough. Now that's example 5. I don't need example 5. Let's find example 2. Oh, it's down here somewhere. Okay, what a mess. That's okay. Okay, so now I'm down here at example 2. The first thing that I'm going to need to do, there's two things happening to my variable. There's a negative 3 is being multiplied, and it's also being square rooted. The first thing I need to do is get rid of the negative 3. It's being multiplied, so the inverse is divide by negative 3. So I'm left with the square root of x equals 6. How do you undo a square root but square it? Okay, so squaring the square root leaves me with just x, and 6 squared is 36. Let's do an example 3. There's 3 things happening here. I've got a 2 times, I've got a square root, and I got to subtract 5. So you're going to get rid of the 5 first by adding it. The inverse of subtraction is addition. And then I'm left with 2 square root of x equals, because I keep zeros out, 4. How do I undo the 2? Divide by 2. Square root of x equals 2. Well, x is still not by itself, so I'm going to square it. Undoing that square root, x equals 2 squared, which is 4. All right, good. Let's go find example 4. Where do you think it is? Oh, here it is, down at the bottom flap, which is not extraneous solutions, actually. This is looking at now radicals on both sides. So let's do that then. We have to first, in this situation, there's nothing outside of the radical, so the first thing that we're going to do is get rid of the radicals. How do I undo a radical or the square root? I'm going to multiply the whole thing, or not multiply it, but square it to get rid of that square root. Put it in parentheses because that means I want the whole thing squared to get rid of the entire radical. So then I'm left with x plus 4 equals the square, excuse me, yep, 2, not the square root of, 2x minus 1. And then I just solve for x. You can VC. What variable's already over here is x. What variable has to come over? A positive 2. So I'm going to make it into a negative 2. X. What constant's already here but a negative 1? What's coming over? Going to make it into a negative 4. Combine like terms. X minus 2x is negative x equals negative 1 minus 4 more is 5. Negative 5. And last step, divide by negative 1. X equals 5. Simple enough. Let's go searching for example 5. Should be together, but it's not. That's okay. Okay, so now, again, radicals on both sides. There's nothing outside of the radicals. So the first thing that I'm going to do is get rid of them. How do you undo the square root? But square it. So I'm left with 3x plus 8 equals x plus 4. All right. Then what do? VC. But variable's already there, 3x. And what's going to be coming over? A negative x. All right. And then I'm going to have 4 over here as the constant there. Bring over a negative 8. I'm left with 2x equals negative 4. Divide both sides by 2. X equals negative 2. All right, example 6. All right, example 6 is where we're starting to look for these extraneous solutions, which essentially means a solution that's not going to work for our equation. Okay, so here, the first thing that I'm going to do, I have a square root, and I'm going to need to undo that. There's nothing happening over here, but I do have a square root across all of this, so I'm going to have to square everything on both sides to get rid of that square root. So I'm going to square all of this to get rid of the radical, and I'm also going to have to square this x. So I'm left with x squared equals 42 minus x. Well, then what do? I can't subtract x. Those are not going to be like terms, but what I am going to be able to do is factor. So let's put this in standard form. So I have, remember standard form, it's that ax squared plus bx plus c equals 0. Okay, that's what we're looking at. So I'm going to have to bring everything over and to make my equation equal 0. So I'm going to have to subtract 42 and add x to both sides. Okay, so what am I left with? X squared, because I couldn't combine it, plus x equals, or no, excuse me, minus 42 equals 0. Good. Now I can factor. What two things? Multiply to negative 42, but add to x. And so what are your factors of 42? We have 6 and 7. I need my answer to be positive, so that means then 7 is going to be positive, and 6 is going to be negative, equals 0. And then what do here? Don't forget you can break it down into 2 equations to solve. All right, so I'm going to bring it up here. X minus 6 equals 0, and x plus 7 equals 0. And then just solve for x. So I'm going to add 6. So x equals 6. And I'm going to subtract 7. X equals negative 7. But now I solved, but I need to check for extraneous solutions. So potentially one of these, even though I solved for it, one of them is not going to work for my equation. So I'm going to have to plug in both to see if either of them work. So plug in 6 for x. Okay, so 6 equals the square root of 42 minus 6. Well, the square root, 42 minus 6 is 36. Does 6 equal 6? Yes. So this solution works. Plug in the 7. 7 equals the square root, negative 7, thank you, equals the square root of 42 minus negative 7. Minus a negative is the same thing as plus a positive. So negative 7 equals, we have 42 plus 7 is 49. Does negative 7 equal 7? The answer is no. That's my extraneous solution. All right, let's find example 7. I think that's our last one. Okay, so find example 7. The first thing that I'm going to do is get rid of that radical by squaring it. If I'm squaring the left side, I gotta square the right side. I'm left with 2 minus x equals, this is x plus 4 times x plus 4. So let's write that. All right, that's a FOIL thing. You can FOIL it or you can use the box method to solve that. So I have then 2 minus x equals x squared plus 8x plus 16. I'm going to factor. Not yet. What do I need to do? I need to move this stuff over because I need to make my equation equal to 0. So I have to subtract a 2 from my constants, and I also have to add an x to make that all equal 0. X squared, I have plus 9x plus 16 minus 2 is 14. I need two factors that multiply to 14, add to 9. You know that that's going to be 2 and 7, and they're both going to be positive. And then I'm splitting into two equations. So then you can set up 0 equals x plus 7, 0 equals x plus 2. Subtract 7, so negative 7 equals x. And then negative 2 equals x. But I have to check for my extraneous solutions. So that means I'm going to have to take these both, plug it into my original equation, and see if it works. So let's try negative 7 equals x. 2 minus negative 7, square root of that, equals negative 7 plus 4. Well, 2 minus negative 7 is just the square root of 9, because the same sign, I can keep change, equals negative 7 plus 4. 3 equals negative 7 plus 4 is negative 3, so this does not work. That's a big no. That does not work. But we're going to check the other one just to make sure that the other one is correct and it does work. All right, so I'm going to check negative 2 equals x. So I have 2 minus negative 2, square root, plugging it into the original equation here, equals negative 2 plus 4. We'll keep change. So the square root of 4 equals negative 2 plus 4. Square root of 4 is 2, equals negative 2 plus 4 is 2. So that works. So this is my solution that works. That is my solution to the problem. All right, for homework, for your left-hand page rather, I want you to, let's say, do the evens, but I want to go ahead, I want you to try 18, even though you haven't done it yet. We haven't done a division. All you're going to do is square both sides and then multiply by 6 to get rid of that 6 down there, okay? If you've got questions, feel free.